Okay, z-scores for value of the random variable. So here's just a quick review of z-scores. So z-scores represent how many standard deviations you are considering. So z would be kind of like the number of sigmas, okay? And we have some of the formulas that we've been using in the past to calculate the z-score and the standard deviation for both a population and for a sample. Now, the distribution of the z-scores of a normally distributed variable is standard normal distribution with a mean of 0 and a standard deviation of 1. So areas under this normal curve are known to be a very high degree of accuracy and can be printed in a table format for easy reference. And all of you in my class have been given this table. Okay, and this is how the table looks like. So for a mean value of 0 and a standard deviation of 1, these are your probability density values, the area under the curve. Okay, so a z-score, two things for a z-score. So it indicates the number of standard deviations a value lies from its mean, and it converts a normal distribution to the standard normal distribution so that z-scores can be used with areas under the normal distribution curve to find probabilities. Okay, so just a difference now. There's just something, so your data can be modeled using a normal distribution, but we use z-scores to standardize your normal distribution to a standard normal distribution. So standard normal distribution would have probabilities all listed under this table. So you can calculate the probabilities or the probability density for any range of values, continuous variables, using a standard normal distribution. But you can only get the standard normal distribution by converting your normal distribution through the use of z-scores. Okay, because z-scores are considered like these are the standardized numbers, right? Okay, so let's look at an example to help us understand this. So example 3. Normal probabilities. So all that glitters, a Sparkly cosmetic powder, is machine packaged in a process that puts approximately 50 grams of powder in each package. The actual masses have a normal distribution with a mean value of 50.5 and a standard deviation of 0.6. So the manufacturers want to ensure that each package contains at least 49.5 grams of powder. What percent of packages do not contain this much powder? Okay, so we're looking at what's the question essentially? What is the probability that a package X, its mass, is less than 49.5 grams? Okay, visually, we're looking at the normal distribution, and here's 49.5 grams marked. Our mean value is 50.5, as it says in the question over here. So what is the probability that the X is going to be less than 49.5? It's the blue section right here, the area under this curve. Okay, now I can't necessarily calculate this right now. This is just a normal distribution for our sample. Okay, and we don't even know the values. We're just told, it's a pretty good estimate to estimate these things using a standard normal distribution. So you have a mean value. You target your mean value when you're making a packaged product, and not every product is going to reach 50.5, okay, or 50 grams. So some are going to be below, some are going to be a little bit more, some are going to be a little bit less. All right, so we just want to kind of minimize that. So we use a normal distribution to model the problem. Now, how do I calculate the area? How do I find what I want? Well, you need to use the standard normal distribution, the standardized one, okay? Because here, the standardized one, we have all the area values, the probability values that we need to find, okay? Now, to standardize it, we've got to make use of our z-score. So we're going to find the z-score for 49.5. So the z-score is equal to x minus the mean value over the standard deviation, which is 49.5 minus the mean value of 50.5, and the standard deviation is 0.6. Okay, so remember, a normal distribution only needs to be described by its mean value and standard deviation. And once you have that, you can take any value on your normal distribution and convert it to a value on a standard normal deviation. So that's our z-score. Okay, so in our standard normal distribution, 49.5 becomes negative 1.67. So z is equal to negative 1.67. Okay, so essentially what this does, it takes our problem, the probability of x being less than 49.5, and you can rewrite the standard standardized equivalent of that as a probability of z being less than negative 1.67. And using so this is what you need to do to find that probability. Go to your z-score table, okay? And the z-score table lists all the probabilities, lists the shaded area for all the probabilities less than z, okay? So it's always going to be on the left side. It's always on the left side of that value. So if I'm interested in negative 1.67, I'm going to go here, negative 1.6. Here it is. Now the columns are distributed by the second decimal place. So 7 is my second decimal value. I'm going to go here 0.07. So negative 1.6 all the way to 0.07. So that value right there. So 0.07, negative 1.6. And so the probability is 0.0475. Let's write that down. So 0.0475. So what that says is that the blue shaded area, okay, the left side of that z-score, that value represents that area. So this value of 0.0475 represents the area of this blue shaded region. So my conclusion is, if I round this, it's going to be about 4.8% of packages contain less than 49.5 grams of powder. Okay. Example 4, standardized test scores. So to qualify for a special program at university, Sharma had to write a standardized test. The test has a maximum score of 750, with a mean score of 540 and a standard deviation of 70. Scores on this test are normally distributed. Only those applicants scoring above the third quartile in the top 25% are admitted to the program. Sharma scored 655 on this test. Will she be admitted to the program? So given all these numbers here, and it might be confusing, but it's just, you look at mean and standard deviation. We're talking about a normal distribution, standardized test scores, right? So test scores, most people, if a test was made, on average, your population will have there'll be a mean value for your population or your sample, and a certain number will be above this average, and a certain number will be below, and then we use a normal distribution as a good way to model this problem. Okay, now to find our probability values, in the absence, we can't really find an area under the curve, right? So you have to use the area under the curve given of a standard normal distribution. So to find that standard normal distribution, I need the z-score. So the z-score here will be z equals x minus mu over sigma. And using the value here, Sharma's score is 655. And the mean value is 540, and standard deviation is 70. Okay, and so that z-score is 1.64. Okay, so if you had a standard normal distribution, you have some mean value. Remember, the mean value for a standard normal distribution is 0, and your 1.64 standard deviations above that. If I were to look on the table for 1.64, then so this z-score table, I can find the area under the curve. So it would represent Sharma's probability density would represent that. Okay, but let's look at the question. Will she be admitted to the program? So 1.64, that means Sharma's score is 1.64. Remember what z-score means? It's just how many standard deviations. So it's 1.64 standard deviations from the mean. Okay, so what does that mean? Well, let's look at one standard deviation. Okay, one standard deviation, back up here. One standard deviation represents, well, remember 34%. This half of it would be 34%. and the entire left half of the normal distribution from the mean, left side of the mean, is 50%. So 50 plus 34% is already 74%. A 74%. That's just one standard deviation. Now Sharma is 1.64 standard deviations. Okay, so that means if mu plus one standard deviation is equal to uh, approximately 74%, then 1.64 standard deviations, so mu plus 1.64 standard deviations would be greater than, well, definitely greater than 75%, right? So that means she would be in the top 25%. So she would be in the top 25% of admitted students into the program. So the percent area tells us where her placement is. So she is well above the third quartile. Okay, so let's look at example number 3. Charlie Brown is trying out for the school football team. He wants to know how far he can kick the ball for a field goal when Lucy isn't holding the ball. The table shows the data from 20 trials. So if you don't know Charlie Brown comics, Lucy always holds the ball. Charlie tries to kick it, but she takes the ball away, and a good laugh ensues. Okay, so this is the situation. So here are the different trials, 20 different trials. Part A, determine the mean and standard deviation of the sample data. So the mean value for sample data is represented by x bar, and that's equal to the sum of all the values divided by the total number of values. And if I took every one of those values, 17 plus 27 plus 31, I'm going to take all those, but I'm not going to write them all out. The last digit down there is 21, and I divide it by 20 because there are 20 trials. All of that would equal 754 on the top divided by 20 on the bottom, which is 37.7 yards. So that's my mean value. Okay, so what about the standard deviation? Standard deviation is going to be governed by this formula, x minus x bar squared divided by n minus 1, or you could use the other formula that was given to you. But if you put this into Excel and you calculate the standard deviation, you get a standard deviation of 9.567. So then what is the probability, part B, what is the probability that Charlie Brown kicks a distance of less than 30 yards? So 30 yards on our standard normal distribution, the z-score would be 30 minus 37.7 divided by 9.567, which is negative 0.805. So almost a full standard deviation below the mean value. So here's my bell-shaped curve. We're about around here somewhere. Okay, z equals negative 0.805. And so the probability of that, that the z-score is less than negative 0.805, or you could say the probability that Charlie Brown's trial is less than 30 yards, less than a distance of 30 yards, is equal to, if I go my z-score table, negative 0.8. Where's negative 0.8? It's right about here, negative 0.8. And the second decimal place is 0.5. Well, I'm going to round up to 1, so let's just say it's right, this value right here, so 0.209. So I'm reading it, second decimal place is 0.01, so my probability is 0.209. Back here, so the probability is equal to 0.209. 0.209. Right, so there's about 21% chance that Charlie Brown kicks the ball a distance of less than 30 yards. Okay, remember the area under the curve represents the left side of the z-score. And I should say the probabilities that are given to us in the table represent the left side of the z-score. All right, see, what is the probability that Charlie Brown kicks a distance of more than 30 yards? So this is just using the indirect method, so the probability that the ball is more than 30 is equal to 1 minus the probability of it being less than 30. And so this is very common with the more than questions because the z-score tables only give you the left side. If you want everything above it, you have to subtract it using the indirect method. Okay. So this case, it's 1 minus 0.209, which is 0.791. Part D, what is the probability that Charlie Brown kicks a distance of 20 yards to 40 yards? So we're interested in the probability that x is between 20 and 40, which is the probability that it is 40 minus, sorry, I should make this properly, x is less than 40, minus the probability that x is less than 20. Okay, and for you to visualize that, there's a normal distribution. If for example, x was 40 over here and 20 over here, then the z-score table would give us, if we did 40, all of this stuff, all this area. But we don't want all of this area. We just want the area between 20 and 40. So if I calculate the area of 20, then the z-score table will tell me this portion right here. And so when I subtract where the two meet, then I have the middle portion between 20 and 40. So that's what's happening here. Okay, so let's find the z-score for 20. So the z-score for 20 is equal to 20 minus 37.7 over 9.567, and that's equal to negative 1.85. And the z-score for 40 is equal to 40 minus 37.7 divided by 4.507, and that's equal to 0.5103. So let's look up these probability values for negative 1.88. So negative 1.8, the second decimal is 8, so right over here, 0.0301, so 0.301, and the probability for 40, for 0.5103. So let's go to positive 0.5 right about there, and the second decimal is 1, so 0.1 right there. The probability is 0.6950, so 0.6950. So therefore, the probability that x is between 20 and 40 is equal to 0.6950 minus 0.301. And if I take out my calculator, the answer to that is 0.394. So equal to 0.394. So there's a 39% chance that Charlie Brown kicks a ball that goes between 20 to 40 yards. And that ends 7.2.